Howdy, and welcome to my video on nonlinear inequalities. In this video, I'll be going over, nonlinear inequalities. I'll be going over how to solve them using a sign chart. These problems have been taken from a virtual math learning center. A link to these problems will be put in the description. Alright, so let's start with the first question. So we have negative x squared plus 9x greater than or equal to negative 22. We always want to zero out one side. So I'm actually going to bring this one over here because it makes more sense to me. So we'll have 0 greater than or equal to x squared minus 9x minus 22. If you refer to variables on the left side, then you can just flip everything around. So x squared minus 9x minus 22 less than or equal to 0. Okay. Now we need to factor this, right, to find out critical points. Critical points are just any sort of points where there's a shift, a potential shift from a positive to negative, negative to positive. These can be asymptotes, these can be holes, these can be actual x-intercepts, okay? So we're looking for two numbers that multiply to negative 22 and add up to negative 9. This would be negative 11 and positive 2. So we can rewrite this as x squared. How do I want to do this? Let's do minus 11x plus 2, actually no, plus 2x minus 11x minus 22 less than or equal to 0. And we get, from the left side, the left 2, we can take out x, and we get x plus 2. From the right side, take out minus 11, get x plus 2 less than or equal to 0. Take out the common factor and add the rest. And this is our factored version of the problem. Now, our critical values are when we hit exactly 0. So you have x equals 11, and we have x equals negative 2. So our sign chart is going to be like this. We're going to have negative 2 and 11 be our boundaries, okay? So remember our critical values, right? Generally speaking, they should have from positive to negative, or negative to positive, right? Because if your graph ever crosses this x-axis, right, from like positive to negative, or negative to positive, right, you have to go through the x-axis. And that's why these are, your critical values. And the reason this is important is because we have 0 as our constant, right? So if you cross a critical point, right, which we find by using 0, you're going from less than 0 to greater than 0, or vice versa. It's also easier to identify the regions we want because, like in this case, right, we're saying that, less than or equal to 0, I want everything below the x-axis, including any points that happen to be on the line itself. Okay? So we're looking for negative regions and 0 regions. Okay? So we know that our boundaries, right, our critical points will be included, but now we just need to find the negative regions. So all I have to do is test a point in each region. So let's say negative 3 for here, 0 here, and 12 right here. If we plug into our factor equation, right, we get for negative 3, we get negative 3 plus 2, negative 3 minus 11. This is a negative number. Actually, this is negative 1, negative 14, right? So negative, negative, which means this is a positive region. For 0, we get 0 plus 2, 0 minus 11. this is 2 times negative 11. So positive times a negative will give us a negative. And for 12, so we have 12 plus 2, 12 minus 11. We had 14 and 1. That's positive, positive, and positive. You see, every time I go across a critical point, I switch the sign, right? And note that, like I said, you cannot, like a region cannot be both positive and negative, because for that to happen, you would have to cross the x-axis, right? So by testing one point, you can see where the entire region is above or below the x-axis. So we're looking for less than 0, right? I'm looking for less than or equal to 0. Less than 0 means negative, so we want this region right here. Right here, right? So we would do negative 2 inclusive to 11 inclusive, right? So again, the 0, right? We can test that. We tested already. But actually, we can just retest with the original, right? So we have negative 2 squared plus 9 negative 2. This is negative 4 minus 18, which is negative 22, which indeed is greater than or equal to negative 22. We plug in 0. We get 0 greater than or equal to negative 22. Perfect. And if we plug in 11, you get negative, what was it? 121, right? Then plus 9 times 11. This is negative 121 plus 99. That doesn't look too right, does it? 20. I mean, that should be 22 as well, right? Yeah. This is negative 22, which is greater than or equal to negative 22, which is perfect. All right. So question 2, it's actually already factored for us, so that's really neat and dandy. So we just need to solve for when it's equal to 0, right? Find our critical points. 1 minus 2x equals 0. Now 1 equals 2x, x equals 1/2. For this one, x plus 5 equals 0, x equals negative 5. Okay, now sign chart. So you have negative 5 and 1/2. Okay. Just let me move this down a bit. Take this. Bingo. Okay. So we can test the point in between. So we can do like 0 right here. We do 1 and negative 6. Okay. So for negative 6, we have negative 6 plus 5 cubed, right? And then 1 minus 2 times negative 6 squared, right? This is always positive, right? Something squared is always positive. And now we have a negative 1 cubed, which is negative. So this entire region should be negative. And put in 0. We get 5 cubed times 1 squared, which is positive, positive, which is positive. If we put in 1, we get 6 cubed, 1 minus 2 squared. So that's positive. Anything squared is positive. So that's another square. So our only number that works would be anything negative 5 and down, right? But there's no equal, right? It's missing. So it's actually anything below negative 5, but not including. So it's negative infinity to negative 5 exclusive. You might be wondering, right? I already said, like, usually almost all the time it bounces. Like, it goes through, right? So it'll be plus, and this should be a minus, right? But if you remember from graphing, and how multiplicities work, right? This is an even multiplicity, right? That means at the graph, at that point, it's going to stay positive or stay negative, which means both sides will be the same. So plus plus, that matches the multiplicity. And the multiplicity at -5, right, is odd. So it should go from negative positive, like this. I'm sorry. It should go from negative positive like this, or positive negative like this. And you have negative positive. So that is a change, and that is correct. Okay. Usually you see questions with odd multiplicities, which is why more often than not, you think that, oh, everything should switch. Be very, very careful, and that things will change up on you. Okay, so for our third question, right, 9x squared plus 6x plus 1 greater than or equal to 0. We already have 0 on one side, so all we have to do is factor. I'm looking for two numbers to multiply to 9 and add up to 6. That's 3 and 3. We can rewrite the left side as 9x squared plus 3x plus 3x plus 1. Take a 3x from the left too, and get 3x times 3x plus 1. Take out 1, you get 3x plus 1, right? Common factor, so 3x plus 1, add the rest, 3x plus 1. Okay? So we have 3x plus 1 squared, so we combine, right? And then we add in the whole thing, greater than to 0. So we have a critical value, right? And it's x equals, we have 3x plus 1 equal to 0. 3x equals -1. X equals -1/3. Okay. So when we make our sign chart, there's one critical point, -1/3, and we'll just test the number left and right. We can do -1 and 0. So for 0, you get so 3x plus 1 squared, right? So that'd be 1 squared, which is simply positive. So that's a positive. Oop. And then -1, we get -3 plus 1 squared. But again, anything squared is positive, so that's positive. The entire thing is positive, but we don't have an equal, right? So it's every value but the critical value. So our domain, or our solution set is -infinity to -1/3 exclusive, union -1/3 to positive infinity. That is our solution. For 4, we already have a 0, so that's good. Now the trap is to undo the square, right? Oh, take the square root and solve. You do not want to do that, right? You want factored form. You want everything to, stay together. Do not remove information, right? Don't take the square root like this. This is a big no-no. Just keep it like this, right? You want to find a 0, so x minus 100 equals 0, x equals 100. And now, we just make our sign chart. Sign chart goes like this. And we have 100 here, okay? We can test out 101 on the left and 0 on the right. Wait, sorry, 101 on the right, 0 on the left. For 0, we get -100 squared, right? Anything squared is positive, so it's positive. For 101, we get 101 minus 100, which is 1 squared. So that is also positive. So note that we need less than, right? This needs negative regions. We don't have any. Luckily, we have this equal sign right here, which means our only solution is actually 100. So the set of whole values is just 100. And that is question 4. And with that, that is the end of this video.